Response to change, feedback loops and ecosystems. We did feedback loops very briefly and population control. But I want to look at when feedback loops get out of control. So we wanted to see whether a system is in equilibrium, positive or negative feedback, and be able to explain observational data that may be showing a feedback situation. And we need to have you able to speculate whether we have set in motion unstoppable environmental consequences due to human interference in the natural systems in the environment. So once again, feedback is where a situation like a microphone, you yell into it, and when your yell comes into the speaker even louder than before, the microphone re-amplifies that, sends it back through, it comes out louder again, the microphone grabs it, it comes out louder again, and very quickly it goes to that squeal. Uncontrolled positive feedback is going to destroy this. It'll just go into the screeching mode and stay there. There's this equilibrium. All right, you have to counteract what gravity is going to do. In the human body, we have many reflexes and actions that provide negative feedback. If we are jolted to the left, we'll lean to the right. Our active balancing requires the constant use of negative feedback so we don't tip over. Pupils. In response to bright light, the eyes not only close the pupils, but literally act to make the chemicals in the retina less sensitive to light to the point you become blind for a few minutes when you re-enter the dark. Okay? A ship sinking. A ship has a wave go over it, fills the boat slightly. Now the ship sits lower, so smaller waves can now cross the bow and enter. The ship sits lower again, allowing even more waves to enter. The system runs away and the ship sinks. Obesity can go into a positive feedback loop. A person feels run down, so is inactive. They gain weight. The weight makes them feel more tired and inactive. They rest even more, eat even more, and then the weight gains again. Each step forward causes the weight to gain, and it accelerates. Poor control design was responsible for a lot of deaths when jet skis came out. They had pull throttles. So the person would squeeze the grip, the vehicle lurches forward, causing you to lean backward, and you grab the throttle harder and cause more of an effect. And there was a real problem in the 80s that people would get on the jet skis, squeeze the triggers, and then go completely out of control. So they switched to twist throttles that you twist away from your body. So if you suddenly lurch backward, you will undo the throttle and slow it down. Here would be a graphical example of an area where you can decide where is there negative feedback and positive. So when this person in the valley attempts to dislodge this ball from the center, will gravity try to return it to the center, which would be negative feedback, or will gravity help this person? This, if they succeed in getting the ball right to the peak and they give it one more shove, will gravity accelerate the ball out of control, or will it stop the ball from leaving the top of the hill? So I think you realize in between the peaks in this valley, gravity will provide negative feedback. But if you get the ball to this edge, it turns to positive feedback and there'll be no stopping it. So what things in the environment have we done that may be going into a positive feedback situation? Here's a case of positive and negative feedback leading to an equilibrium. The system wobbles up and down, but whatever is counteracting it is also going up and down, and it settles in. So at home, when the furnace warms up, there's negative feedback that shuts the heat off. Then when it gets cold, it triggers the system, turns it back on again. The temperature in your house won't stay rock steady on one temperature, but it'll just wiggle up and down if it's in equilibrium. One situation that's really dangerous at home is called thermal runaway. You plug in a cord that's too thin. The cord gets hot because of this. But when cords get hot, they actually resist the electricity more. which means they'll get hotter again when they do that. And as they get hotter again, they'll resist more, which causes more heat to build up. And this process can run away and the wire actually catch fire. So cooling fans and little switches that will turn the heat off is there to stop thermal runaway. Here's an example of negative feedback in the situation. As the predator population goes up, it's pulling the prey population down. So it's counteracting the prey's tendency to grow without bounds by pulling it down. Throwing food on the ground would be positive feedback. It would increase the rabbit population. Okay? When you kick a rock down a mountainside, if it triggers an avalanche, that's positive feedback. The system is not in equilibrium, and if you can try to get that rock back, it doesn't matter now. We may be doing this now with carbon dioxide. We may no longer be in control of the situation, and with each passing year, the evidence I get is that we've lost control. And here's why. These ancient frozen swamps are all over the northern part of the world, in Canada and in Russia. These frozen swamps, when they thaw, they release CO2 and methane to the atmosphere, which causes global warming. So here's what happens. The glacier melts back because we've warmed the earth with our pollution. This ground thaws and begins to spit out more carbon dioxide, which helps warm the earth more, which makes the glacier melt back more, which exposes more soil, which rots, puts more CO2 in the atmosphere, melts it back again. The evidence now seems to be that this positive feedback cycle has now started. Meaning, if tomorrow we shut down all the cars in the world, controlled all our CO2 emissions, stopped them, the entire Canadian Arctic and the Russian Arctic are now kicking out more CO2 than anything else. And so global warming is now running away on us, and we won't be able to stop it. Do I believe that? Yes, actually. Read enough data that it doesn't really matter now. Your children will have a different world. This is now out of control. It's an avalanche of CO2. So, what I like to think of as human beings, we took this ball and we pushed it and we pushed it and we pushed it. And the scientists were warning us here. And by about 1990, when I started my teaching career, we've pushed the carbon dioxide ball to here. It's now beyond a natural limit. Nature, the shape of this hill, could only control the movement of the ball with negative feedback between these two peaks. Once we've pushed it too far, gravity now takes over. Okay, and we're going to watch some of these videos in class and discuss them. It's very depressing, but all the evidence now seems to be that we've triggered a positive feedback loop with CO2, and the levels will continue to climb whether we stop our behavior or not, because we just pushed a little bit too hard.